Hello, my name is Sean Gomez and I'm a systems engineer at Cisco. Today, we're going to be taking a look at how to make your life a little bit easier with APIC-EM. Now, this is the maiden flight of config bytes in a video format. Traditionally, I've done these on my blog, text-based, and I'm trying something out new here, especially with the demo that you'll see later. So I just wanted to encourage you to leave feedback in the comment section or tweet me at Cisco_East and let me know what you think about this new format. So hopefully by now you've heard about Cisco's Digital Network Architecture, or DNA. If not, let's do a recap quickly. There are three main goals of DNA: faster innovation, lowering risk with built-in and inherent security, and finally reducing the cost and complexity with automation and orchestration. This is all part of our software-defined approach for the campus, LAN, WAN, and wireless environments. Today, we're going to focus specifically on reducing cost and complexity using APIC-EM. So what is APIC-EM? Well, let's just start by getting this acronym out of the way. APIC-EM stands for Application Policy Infrastructure Controller Enterprise Module. I know it's a mouthful and I apologize for that. But the one thing that I typically get asked when I do these presentations is, well, I've heard of APIC before. Well, we have Application Policy Infrastructure Controller, and we've had it for quite some time in the data center space. But this is not the ACI controller. Again, APIC-EM, think of EM, the enterprise module, as everything for campus, LAN, WAN, and wireless environments. And then we have APIC for the data center, which is also sometimes known as ACI, or application-centric infrastructure. So I just wanted to make clear the delineation between the two APIC controllers. Cisco's SDN controller for the campus, LAN, WAN, and wireless network devices, as we stated before. So what we're trying to do here is policy-based abstraction of the network, which is intent-driven. In other words, typically with something like QoS, you have to know the platform and its capabilities. Does it support 4 queues, 8 queues, 12 queues? And then you have to craft the configuration, the syntax, the CLI to match that platform's capabilities. And what we're simply stating with policy-based abstraction is, I'm going to tell you, the APIC-EM controller, this is my intent, this is what I want you to do, and then you go figure out how to program the infrastructure. So really simplifies the way that you deploy, and for example, like QoS. It's the core component of Cisco's digital network architecture, and specifically focusing in on the automation and assurance piece. So what challenges are we trying to solve? Well, number one, we're trying to reduce cost and complexity. Now, a lot of times engineers, when I do these presentations, are like, oh man, this is going to put me out of a job. No, it's not. It's making your life a little bit easier so you can focus on more important things such as architect, new designs, optimization of the network, so on and so forth. Hey, and if it gives you a little more time with your family, nothing wrong with that either. So we're also trying to address a major issue with time consumption. When you install new networks, you deploy new branch sites, sometimes they're very time consuming and a manual process. What if we can do this with minimal touch? We also are trying to make APIC-EM the single source of truth for network devices, since we know that's always been a difficult task at hand with different network management systems. Troubleshooting application flows through the network can be complex and time consuming. That's another big challenge we're trying to solve with APIC-EM. So how do we solve these challenges specifically? Well, we automate provisioning to accelerate time to deploy and reduce costs. You'll see that with one of the base applications is called the PlugandPlay tool, or the PlugandPlay app. And I'll show that later in the demo. Centralized inventory of network devices to make operating the network a little bit easier. And then we have a really neat base app called Path Trace. Now, Path Trace gives you the capability to pinpoint network performance issues, maybe ACLs that are incorrectly configured that are blocking traffic. And what MTTI is, mean time to innocence, right? The network's uh, always guilty until proven innocent. So mean time to innocence, we're trying to accelerate the time to identify these issues and prove that the network is in fact innocent or is guilty. Extensible with the ability to expand upon the base app. So I keep saying base apps, and you'll see when we go through the demo, I'll identify what the base applications are within APIC-EM. But I also want you to know that it's extensible in so much that we can add new applications. We've already done this with the iWAN app, and there's more to come. So one of the coolest things about APIC-EM is it's free, totally free. The only thing is that if you're looking for support, we ask that you have the devices that are in APIC-EM under a SmartNet contract, valid SmartNet contract. But if you have a device that's in there under a valid SmartNet contract, support is even available for you. The controller and the base applications are free. Tax support, like I said, if you have an appliance, physical appliance, we have this in two flavors. You can either download the virtual machine or you can run this on a standalone appliance. If you have the standalone appliance and that's under maintenance, you also are granted support. Now, the one thing that I always stress is how much memory is required, and it's a pretty hefty amount. 64 gig of RAM is recommended. 32 gig is minimal for a successful install. You can deploy this in a high availability multi-node cluster, and each cluster node requires 32 gig of RAM. If you're going to be testing this in the lab and maybe not taking advantage of something like the iWAN application, 32 gigs is going to be fine, but for production environment, we highly recommend 64 gig. There's a promotion going on right now. I'm not going to get into it, but basically, if you spend $600,000 or more list price, you qualify for a free standalone APIC-EM appliance. Please reach out to your account team at Cisco for more details on that offer. How do you get APIC-EM? Well, in this video, I'm going to embed these links so that you can click them, but basically you can go to DevNet, which is developer.cisco.com, simply search for APIC-EM, or you can go right to the Cisco homepage, cisco.com, support, download, and then type in APIC-EM. Two ways to get it, and download the ISO, and you can get started right away. So with that, it is now demo time. Now keep in mind that this is our first step in our journey to simplification. So as we go through this, I will go ahead and point out, as I said earlier, the most important thing are what are the base applications that you get and which ones are optional or are added later. So without further ado, let's get right into the demo. Okay, so let's dive right in. With APIC-EM, you'll notice the very first screen we show up on is the dashboard. So we log in, we're at the dashboard, gives you a high-level overview. If you are used to any other network management system, Prime Infrastructure, SolarWinds, What's Up, Gold, I think is what they're calling it these days, again, or Professional, I can't remember, let's just say WUG, they all have some concept of a dashboard. High-level overview, here's my device inventory. You noticed a second ago, you probably took notice that one of them was in progress, so it's continually updating. And do we have any unreachable devices? No, everything's good. We're in a healthy state. If I was using the iWAN app, these branch sites would be also on here, but I didn't provision that. Path trace, that's a really neat tool we'll get into. All path traces are successful. Those are ones that are set up as active path traces. So again, they're continually monitoring that path. Easy QoS, and then network plug and play. So let's go into the system health real quick. Gives you an overview, CPU utilization. You can hover over any of these statistics and get more details. Memory utilization, storage, and then services. So services, daemons, whatever you want to call it. These are basically all the key services that run behind the scenes to make APIC-EM work. And you got up, down if it's red, up if it's green, warning if it's yellow, and then in progress. Normally you'll see that when it's starting, if APIC-EM is reloaded. But those are your status, that's your state there, and then here's the services. And then we go to system info. Now this is really important. So system info shows you what version you're running, 13237. You can also go to the settings gear at the top right and go to about APIC-EM. So you can get your version info right there. But here's a very important thing, is it shows you what the appliance requires specification-wise, physical server requirements, or if it was a virtual machine. So you can see the requirements here. This is for the virtual appliance and this is for the physical appliance. If there's new features, things that we want to highlight, we typically put it here in this section right here. And then the most important thing, supported platforms and supported and software requirements. So a lot of times customers will spin up APIC-EM and just start loading devices, right? And they're like, Sean, this one's not quite working right, or I tried to provision this with the iWAN app and that's not working. Well, you definitely have to check the release notes and make sure that your platform is supported with all the applications. For example, Nexus 3000, I have a switch in here that's a Nexus 3000, a 3064. It'll discover it. It shows up as in the inventory. I can see serial numbers. I can see what version of code's on there. But once I try to do things like path trace or maybe even EasyQoS, it's going to fail because that's not a supported device. So just be sure to check the release notes. Make sure that what you're trying to import into APIC-EM is supported. Very nice, clean HTML interface. On the left-hand side, you'll see the navigation bar. So we can see here, I kept saying about base applications. So let's go through that. What is base applications? Well, everything here, EasyQoS, network plug and play, path trace. I'm going to skip over that iWAN one for a second. Topology, host inventory, device inventory, discovery, and obviously the home. These are all the base applications. The only application that requires a right to use license is the iWAN app. So remember, base apps are free. The only one on here that requires a license is iWAN. And if you already have Prime Infrastructure 3.x, you are entitled to the right to use for iWAN. So let's go through and let's start at the EasyQoS. We're going to start from the bottom and work our way up. Now, many times customers are like, Sean, QoS is a nightmare. Nobody loves it. Nobody enjoys it. So we basically, hear this time and time again. It's got to be an easier way, a better way. Well, there is now with EasyQoS. What I can do with EasyQoS is it really goes back to when I was talking about intent-driven policy, where I don't need to know MQC, right? Modular QoS CLI. Wow, that's bad. We're nesting acronyms within acronyms. Unbelievable. What's the world come to? But basically, MQC is pretty much the universal language to implement QoS on a Cisco device anymore. You used to have MLS QoS. It's still out there. There's still a lot of devices that are MLS QoS based, but multi-layer switch if you're wondering what the MLS is. But by and large, MQC is the standard. But you still need to know, well, it's a switch. How many queues does it support? It's a router. What's my MQC syntax look like? And you end up having to look through so much documentation and go, okay, this is this device, this is what I'm trying to do. Well, now with EasyQoS, let's just show you how easy this is. I basically create a scope, and my scope is like a containment zone. I don't want to blast a policy out network-wide, although I could do that if I wanted to. Here, I'm going to contain my scope to just my remote site 11, which has 3 devices. So let's click that. I have a 2911 router, 2960X switch, and another 2960X switch. I have two 2960s. So I have two switches and a router. Normally, you'd be looking at documentation, how many queues does the switch support, what's the priority queue, etc., etc. Now, let's just show you how easy this is. I have three devices, and I have Sean's QoS policy. So basically, here's my policy, and I can look at this and say, let's look at Citrix, right? Citrix is important to me. Now, these buckets are business relevant. That's important. I care about it. Default, I don't care about it. And business irrelevant, I really don't like you on my network. Think of business irrelevant as scavenger class, right? Well, I looked at Citrix and wow, it's all there, business relevant. Now, this is based off of the Cisco validated design or Cisco verified design. Basically, that's our best practices for QoS, and by and large, it works pretty well. Now, 99% of the time, it may cover what you need, and that 1% needs to be modified for your organization. You may have one application that needs to be modified. No problem, we can do that. But this is using the CVD. So let's just go and say, okay, that's cool. Citrix is there. What about SIP? SIP is, as you all know, voice signaling, right? That's going to be my control, call control, business relevant. It shows up. Perfect. That's exactly where I want SIP to be. What about Skinny? That's Cisco's proprietary call control. That shows up too. Business relevant. That's exactly what I want. RTP, real-time protocol. That's the voice media path. Hey, business relevant. Wow, this is working really good. I haven't done anything other than create a policy that says Sean's policy and put the, looked at these and they're in the bucket. So let's keep going. SAP. SAP's business relevant. That's exactly what I want. Call of Duty. I don't think we want Call of Duty on the network, and there it is. Now, I will say that I did create this policy. Call of Duty was originally in the default category. And I said, wow, wait a second. Call of Duty, if someone's running a Call of Duty server, I love games. I love them in my house, but not my place of business. If someone's running Call of Duty server on my network, I want to put that into business irrelevant and make sure that that's scavenger class, police down, etc., etc. We don't want that. We don't want that on our network. So I actually moved it, and you could see how simple that was. The default was in the default category, and I just dragged it over to business irrelevant. And then I can preview policy, look at the CLI that it's gonna push out, and then I can apply or reapply that policy. And it is as simple as that. Amazing time saver. Now let's talk about Dynamic QoS. This is relatively new. As you can see, it's a beta feature. What Dynamic QoS in a nutshell allows you to do is in a Cisco call manager environment or a Cisco IP telephony environment with call manager can signal up to APIC-EM via the REST API. So we talked about programmability of APIC-EM and how we have an open API, northbound API. Well, Call Manager will speak into APIC-EM and it'll say, hey, there's a call going on. Here's the source destination IP of the endpoint or the IP phone. And I need you to instantiate a policy for calls, for this particular call. And I want to make sure that that policy is ephemeral. It goes away when the call is done so that we're not taking up resources. It's incredibly cool. I haven't had a whole lot of time to play with it, but the potential of this particular tool or dynamic QoS within EasyQoS is that it doesn't have to just be Cisco. It could be any other voice provider, IP telephony provider. It could be Avaya. It could be ShoreTel, right? It could be any of them out there that is willing to program their call control system to speak to APIC-EM and do this. So it's an open API. The sky's the limit. So I just wanted to bring that to your attention. Now, let's say in network-based application recognition, sometimes you hear that term synonymous with AVC or application visibility control. we have a ton of applications. Here you can see 1,323. Let's say the application you're looking for doesn't exist. It's not in our application, our protocol pack is what we call it. Well, no sweat, hit add application, create your custom application, right? Sean's app. You could either do URL, server, IP, or port, traffic class, or you could just say similar to and choose an application, right? Similar to browsing. And it's as simple as that. And that's how you create a new application. So that pretty much wraps up the Easy QoS. Let's move on to Network Plug and Play. Now, we were talking about installing networks and how it can be so time-consuming, manual process, and expensive, quite frankly. Smart hands and everything else that you have to get involved. Well, I also made the promise earlier about how automated provisioning will help you reduce costs, but also the complexity and give you some time back. And this is the tool, the Network Plug and Play tool, that I was very excited to showcase here. So many of my customers, they come to me and they say, Sean, you know, we got some pretty monotonous work to do. We're rolling out new ISR routers, the 4Ks. We're replacing the ISR G1s or the G2s. And we just want to try to simplify that process, automate it, because, you know, we're like zombies just upgrading the code and putting configs on there. So this tool is exactly, you know, what customers have been asking for. And in the past, Cisco's had things like Plug and Play, which was on prime infrastructure. We also had Smart Install, a feature within the switches that you could leverage for zero-touch provisioning. But I think this is definitely the simplest iteration, and this is Cisco's path going forward as far as Plug and Play and automatic provisioning is APIC-EM. So let's take a quick look at some of the neat things that we can do here. So you can see I'm at the Plug and Play app, right? And I'm at the dashboard, and I got a couple things here. I got projects, devices and projects, and unplanned devices. Now let's start with projects. We have we could create a new project here, or I can pick an existing project. So I have an IWAN project, but I have no devices that are associated with the IWAN project. But you could easily manually add a device, the name, what product ID, what's the PID. In the case of upgrading to ISR 4Ks, it would be like a 4300 series or a 4400 series. What's the serial number? Do you want it to have a specific image, etc., etc.? And then you just hit add. Now that could be pretty tedious. If you had 100 devices, imagine sitting there trying to do all that one by one. Would it save you a whole lot of time? Well, what you can do is you can have a bulk import. And a bulk import is basically you take a spreadsheet, you fill out the spreadsheet, and then you can copy and paste. Certain fields are going to be redundant. And then with that spreadsheet, and let me actually show you what that spreadsheet looks like. So this is what the spreadsheet looks like, and it has some variables. It'll give you some information on how to fill out the spreadsheet. But once you have this spreadsheet completed, and we'll go back to APIC-EM, you can see that there's a sample. So I just want to make sure I'm very clear in how I got that Excel spreadsheet to work off of. There's a sample which you can download. Once you're done, you import it, click the import, and then you can associate that to a project once you import that. So that's an easy way to get a lot of devices in here, planned projects, you're working on a refresh, things of that nature. But what about unplanned devices? Ad hoc, you had to replace a router or switch, something died in the field. Well, that's no problem. What the device does in order to communicate with APIC-EM is to make it truly zero-touch provisioning, it's going to use DHCP, specifically option 43. And option 43 in DHCP, or Dynamic Configuration Host Protocol, Dynamic Host Configuration Protocol, sorry, is going to basically say, here's option 43. Option 43 is going to tell it where to go to communicate for the plug-and-play agent that runs on the switch or the router. So let me show you that also real quick. because I think it's very important, because I missed this the first time I went through it. So this is what a typical DHCP scope looks like. This is on my 2911 branch router. So remote site 11 has a DHCP scope called wireless with a subnet of 10.100.100.0/24. Default router is 10.100.100.1, which is the 2911. So that's the gateway for that subnet. And then DNS servers 208.67.222.222. I use that instead of 8888. I'm a little partial. Cisco owns OpenDNS, and it's awesome. It's always available. Just a great service, and it's a little bit more protected. So that's the DNS server that I'm using. Then option 43, and you look at that and go, wait a second, what is that ASCII string and 5 Alpha 1 November Bravo 2 Kilo 4? Like, what is all that? Well, it's a string that when the plug-and-play agent receives that on the DHCP client, he's like, oh, I know where I have to go. Basically, this variable 10.100.200.215 is the IP address of the APIC-EM server. J80 is actually the port 80, right? It could be 443 if you want it to be secure. This is just my lab, so I don't really care about that. So that's really how you do zero-touch provisioning. And I can't stress enough that pay attention to this. You can't just put option 43 IP and then put 10.100.200.215 in my example, because that won't work. It has to be that ASCII string to recognize it. So that's for zero-touch provisioning. You know, if you want to do plug and play, there's also a manual method where if you weren't using DHCP and you know, I don't know why anyone would want to do this, maybe for tests, but you could do a plug and play profile and then specifically point it to the APIC-EM server. So I just wanted to show that because it is kind of buried in the documentation. So let's go back to APIC-EM. Okay, so I said, here's my unplanned device. This is a device that I didn't have planned, but it grabbed DHCP, that option 43 that I just showed you, pointed it to APIC-EM, right? He says, hey, here I am. I'm a ISR 4331. I have an IP address of 10.100.100.3. Came from that same DHCP pool that I showed you. So let's ping him, make sure he's alive. And he's responding, so that's good. Okay. So we'll refresh, and he's unclaimed. So let's go ahead and claim this guy. Okay, this is going through the claim process. I'm going to hit refresh. And we're waiting for resource. Now this does take quite a bit of time, so we'll just let this go through. But this basically will go ahead and auto provision this router, the 4331, give it that config that I specified, and then we'll be off to the races. And it truly is as simple as that. So that pretty much wraps up the plug and play, and let's move on. Okay, let's take a look at Path Trace. Now this is an incredibly awesome tool, and I wish I had a tool like this when I was in operations. But what it allows you to do is to put the source IP, destination IP, source port, destination port, and protocol, sometimes known as the 5-tuple, and then see the entire path throughout the network to see if there's any indication of problems. So let's just go in here and show you, since a visual I think is worth 1,000 words. Basically, we have a source IP of 10.7.2.254 going to a destination of 10.6.34.1. It's basically from my remote site, or RS11, remote site 11, to my headquarters, or Bumblebee BR1, border router 1. And I can see that from the switch, it's going to go ahead and learn about its next hop router via an SVI, or intra-VLAN routing. And then the next hop is the gateway, or the router on site, RS11-2911, and he has a VRF, an output VRF of SPA, or Service Provider A. And then it's a DMVPN tunnel, His destination is Bumblebee Border Router 1, so the hub DMVPN router, and that's coming in on IWAN Transport 1 VRF, and it says everything's successful, no issues. Now, if you were having some problems, you could look at device stats and see if is there a CPU utilization issue, is there a memory issue on any of these devices, but this one looks healthy. There's no issues here. So that's just one of these really neat, very simple overview to show you path trace. But let's get a little more complex. Let's use this example, right? And this happens all the time. Let me go ahead and minimize this. And I'm going to go ahead and try to SSH from the headquarters to the branch router, which is 10.100.101. Uh-oh, it's not working. What is going on here? So I could come in to APIC-EM and I could put in source IP is 10.100.203, which is the Nexus 3000 at the headquarters. You can see that right here. Destination is 10.100.101, which is the router, or RS2911. Destination port is 22. Protocol is TCP. Well, I'm trying to SSH, and it is not working. But there's a red X here, and I click that, and it highlights down here, and it says Ingress Interface View Matching ACE. ACE is Access Control Entry. And there's an access list on tunnel 10 that says deny TCP any equal 22. Well, that's not going to work. I'm trying to use SSH, but there's an access list that's blocking it. I wonder who put that there. So let's go back to the router. And let's take a look. I'm going to telnet to it. It's my back door. Show run interface tunnel 10, and sure enough, access group 101 is in there. Let's take a look. Let's make sure, let's keep APIC-EM honest. So let's look at 101, and sure enough, the very first ACE number 10, sequence 10, is denied 22. Well, that's not going to work. I'm not going to be able to get in, so let's go to tunnel 10, and let's do no IP access group 101 in. Let's save that, and I'm going to exit, and let's try our test again. Hey, look at that. I'm in with SSH, and folks, it's as easy as that. This is an incredible time saver. Now, if I go back to APIC-EM, I want to bring to your attention one other really neat feature. View statistics. You can get a quick look at interface statistics. You know, we always look at output drops when we're troubleshooting. Are there output drops? Are we oversubscribing the interface? Is there not enough buffer to handle microbursts? Well, look at this. You can look right there at the output drops instead of having to log in through the CLI and do the appropriate show command. So these are just, this is just an example of how path trace can make your life easier. Now let's go into the topology. So one of these really neat things is I have this nice visual topology. So all the devices that I have loaded into APIC-EM can give me, it basically draws this topology. Now I prettied this one up. I did some editing to make it a little bit cleaner, but the basic discovery and population of the topology into this blank canvas is done for you. So for example, we have 11 wireless devices and 3 wireless devices. Well, you know what? I just want to combine them. So I just drag that over there, and there we have 14 connected to the, basically this is connected to a 3702 access point. The 3702 access point is connected to the 3850. 3850 is actually acting as a controller. And then for the wireless, and then I have a phone attached. It's learning this through CDP. My gateway at the core, at the headquarters, is the Nexus 3K. Then I have basically my 2 DMVPN routers, Border Router 1, Border Router 2. Different transport paths, one's MPLS, one's Internet. my master controller for IWAN, my cloud node, which is simply DMVPN, my branch router, remote site 11. He's connected, it has a switch, a 2960X, one hardwired device, as well as a phone, an IP phone. And then I have the secondary switch, 2960X, the second switch for additional scale at the remote site. So there's nothing attached to that second switch, it's just there, but I just want to show you how nice that is. Now, what you can do is if we go back to the path trace tool, I'll show you how the topology can be used in conjunction with the path trace. So remember this example where we were doing port 22 and it was being blocked, but then we allowed it. Now I can click View in Topology and it draws and highlights the path. So from the hub site to the hub router to the DMVPN cloud to the remote site, it's actually drawing the path and highlighting that for you so you get a nice visual representation. Now I'm going to go ahead and save this because I like that view. I'm going to actually consolidate all those wireless devices again, save that layout, and make that my default. Yes. Then I'm going to close that window. So this is just a really cool visual representation of your network. If you have a large topology, this is just an awesome tool. And let's continue on to discovery. Now discovery allows me to put devices in here. That's how I load them into the device inventory. So you can create a new discovery. You can isolate it to a single IP address. All right, if I just wanted to add 10.100.101, I could add, I'm sorry, that's the CDP. If I wanted to do a range of IPs, 10.100.101, but I really just want that single device, that 32-bit host, you could go ahead and add just the host. Credentials, these are actually saved credentials. I put these in there. There's a global configuration where you can add those. Or you can do them, yeah, you can add them. I would prefer that you add it globally just because a lot of that stuff you're going to reuse. And then if we go to advanced here, you can tell it which protocol order you want that to be in. So SSH first, Telnet second, or just SSH, no Telnet at all. Right? CDP, if you wanted to give it a seed device, so in my case I have 10.100 200.3, that's my Nexus 3548. I can actually have that be the seed device and allow it to discover devices that it can seed directly off of CDP. Create a name, and then once you have it, it saves your discoveries in here. So if something changes and you want to go ahead and manually refresh it, you can hit start and it'll go ahead and queue that up and just get the latest information from it. But what happens is once you're done with your discoveries, your devices are going to show up in the inventory. And this is just a really cool layout. So I can see which devices they are they reachable, when were they last updated, last inventory collection status, managed. If there was a problem, it would say unmanaged there. And then I can go in here and add a tag. So you can add a location tag, a device tag. Tags can be used as identifiers within other applications within APIC-EM. I can also customize this view and say, you know what, let's go back to status, but I want to see what version of code, and I want to see the platform. You can also do serial number as well, but I prefer not to have all my serial numbers on this video. So here you could see the IP address, the iOS, the version of code that it's running, and the platform. 3702 access point. This is a 3925 router, ISR G2. The core switch at the headquarters is a Nexus 3548. 2911, etc., etc. The whole way down. ASR 1001 is my master controller. And then the name that I gave it, the device name. And then last, like I said, update, uptime. And there's just a whole bunch of other options that you can customize this view. Maybe MAC address, that might be something important to you. Very neat, single pane of glass, and if you're trying to create a single system of truth, right? Like, here's my one place to go to for all my Cisco devices, this is what we're recommending. Host inventory is basically after a device is in the inventory, in the device inventory, now we can look at the hosts that are attached to it, right? So it's discovering these through CDP. Here there's a wired device. Here's the host name. All my wireless clients. It shows the MAC address, the host IP, connected device where it's connected to, which is actually the 3850 switch, because that's the wireless controller for the access point. Okay, so the last thing that I would like to show before we conclude our demonstration of config bytes is the API. And we talk all about this application programming interface and what does it mean. Well, the API allows other programs to interact with APIC-EM. And we call it, basically from the controller's perspective, from APIC-EM's perspective, the southbound API is how the controller interacts with the infrastructure, right? So the switches, the routers, they're southbound from the controller's perspective, and they'll use things like netconf, they'll use SNMP, SSH. That's their interface to the infrastructure devices. But from the controller's perspective, the northbound APIs are basically the APIs that allow other devices, management systems, network management systems. We gave the example of the dynamic QoS tool within the Easy QoS tool, and how Call Manager can speak to APIC-EM and basically signal when there's a new call going on to instantiate a dynamic QoS policy. So that API that's commonly known as the northbound API. And I just wanted to really quick show you some cool stuff. There's a tool called Swagger. So if you're familiar with APIs and programming, and you want to build a Python script that speaks into APIC-EM, whatever you may be doing, maybe you might use Postman to test out some of the RESTful calls. Well, you can actually, instead of having to authenticate the Postman client and go through that with a token, when you log on to APIC-EM, you're logging in my case, I'm an admin, right? Administrative credentials. That allows me to authenticate towards this tool, the Swagger tool, the API tool, and I can actually do tests right here of my RESTful calls. So for example, if I go to inventory and I go to network device, I could say, you know what? Here's this call, get network device. It tells you all about it, and you can try it out. And you see how it basically is showing you, here's the REST call, here's the IP, API, network device. And because I'm already authenticated, I'm not worrying about generating a token and passing that through in the header and all that other stuff that comes along with using Postman to test this. And then here's my response. I believe that's XML or JSON format. But there's my response of all the network devices, and that basically correlates directly to my device inventory right here. So all these devices and the information that we have is being exposed through that API. Go back to inventory, network device, get, and there's a documentation, and that's exactly what we did, and there you go. There's the same information we just saw from the device inventory. So you can see how that's exposed, and there's plenty of stuff for you to test out here. Plug and play basically every tool. There's an option here, inventory, etc., etc. So I just wanted to show you the power of the programmability aspect, especially testing out your own API calls within the Swagger tool right there natively on the APIC-EM. Let's bring this home. Now, earlier I had mentioned that APIC-EM is our first step in our journey towards simplification. And just to recap everything we've done today is we've went over how Cisco APIC-EM is a controller for the campus LAN, WAN, and wireless environment. It provides policy-based abstraction of the network, and has a number of foundational applications which provide immediate value in their own right, as well as capabilities for policy-based applications such as easy QoS and intelligent WAN or IWAN. The foundational APIC-EM applications automate this collection of network information and the deployment of network devices, greatly simplifying and reducing the cost of network operations. So I hope you enjoyed this video. I hope you found this informational and useful. We'll see how this config bytes video format progresses. I think for some content, the video format is great and makes sense. Other content, probably not so much, and a simple blog post will be suffice. So if you have any other questions about APIC-EM, or you're looking for some help to get started, please reach out to your Cisco account team, and they'd be more than happy to help you. Also, most important of all, make sure after you close this video out, you go to cisco.com, support, and in the download section, type APIC-EM, and get started today. Download that image, spin it up, and enjoy. Until next time, thank you.